Lesson 3.1 Graphing Linear Equations. So, upon completion of today's lesson, you should be able to identify linear equations, intercepts, and zeros, as well as graph linear equations. So, our first definition comes from a linear equation. A linear equation is a graph, is an equation whose graph is a line. So anytime we have an equation whose graph is a straight line, then we know that we're talking about a linear equation. Linear equations, they can be written in many different forms. One form that we're going to talk about is called standard form. And that's this form, ax plus by is equal to c. When we're talking about standard form, there are three rules that go with it. Okay, those three rules: a must be positive. So my a value right here must be a positive value. We are not allowed to have any fractions. That's rule 2. And the GCF, the greatest common factor of A, B, and C, must be 1. So if we're going to write an equation in standard form, we have to make sure that it abides by all three of these rules. When we're trying to determine whether or not we have a linear equation, we have these 4 rules. Our exponents on our variables must be 1. We can't root a variable, which means we can't square root, cube root, fourth root. Okay, we can't root a variable. You can't multiply variables by each other. And you can't divide by a variable. So if we take a look at this list here of linear equations, okay, take a look at our linear equations. I got 4x minus 5y is equal to 16. All my exponents were 1. I didn't root any variables. I didn't multiply any variables. I didn't divide any variables. Therefore, it is a linear equation. Same thing happens on the next one. X is equal to 10. My exponent on the x is a 1. I didn't root any variables. I didn't multiply any variables. I didn't divide any variables. And then you'll get that on the next 2 as well. They follow all 4 rules. Now, in our nonlinear equation side, okay, this one gives you an example of each one. So the exponent must be 1. Well, that's y to the second power, so that is not a linear equation. You can't root a variable is number 2. They take the square root of x, so that is not a linear equation. You can't multiply variables. They have x times y, so that is not a linear equation. And then you can't divide by a variable. They divide by x, so that one also is not a linear equation. So my first column gives me a list of linear equations. My second column gives me a list of nonlinear equations. So our first example says determine whether each equation is linear. So it's got to follow those 4 rules. And if it is, write it in standard form. And if we're going to write it in standard form, it has to go back up to b of this form, ax plus by equals c, and it has to follow these 3 rules. So the first thing to do is to check whether or not we follow the linear equation. Okay, so are my exponents on the variables 1? Yes. Did I root any variables? No. Can I multiply any variables? Did I multiply any variables by each other? No. Did I divide any variables? No. So this is a linear equation. So it is a linear equation. Now what I have to do is I have to get it in the form of ax plus by is equal to c, where a is positive. My GCF of a, b, and c must be 1, and I'm not allowed to have any fractions. So the first thing I do when taking a look at this is I know that I don't want any fractions. So to get rid of my fraction, I'm going to multiply the entire equation by the denominator. I'm going to multiply this entire thing by the denominator, which is 2. 2 times y gives me 2y is equal to 2 times 5 gives me 10. 2 times 3 is 6, divided by 2 is 3, so I get plus 3x. So now I have accomplished the rule. I don't have any fractions. Now I need to get it in the form ax plus by. So I need to get this x value and move it to the other side. So to do this, I need to subtract 3x from both sides. Whatever you do to the right side, you must do to the left side. My 3x's cancel. I can't combine, there are not any like terms on the left side, so I'm left with negative 3x plus 2y is equal to 10. So it's in the form ax plus by is equal to c. Now I got to make sure that it abides by all three of these rules right here. A must be positive, no fractions are allowed, and the GCF must be 1. So when I take a look at this, my a value is negative 3. That is obviously not positive, so I have to fix that. To make that to be a positive, I'm going to multiply the entire equation by a negative 1. All this will do will change your signs. So I'm left with 3x minus 2y equals negative 10. So my a value is positive. I do not have any fractions. And then my GCF of 3, negative 2, and 10 is 1. So that is my answer. Now taking a look at 1b, got 6x minus xy is equal to 4. This is not linear. This is not linear because we multiply variables. So when we go down here, we're going to talk about x-intercepts and y-intercepts on the next page. An x-intercept is where the graph crosses the x-axis. Okay? This is where it'll cross the x-axis. It's always x comma 0. The second one is where it'll cross the y-axis. And that is this point right here. It's always 0 comma y. So if we take a look at example 2, it says find the x-intercepts and the y-intercepts for the line shown. Okay, the first one's an x-intercept. This is supposed to say what is the y-intercept. So the x-intercept, where does it cross the x-axis? Well, it crosses the x-axis right there at 2. So it is at 2 comma 0. Remember, all points are labeled as x comma y. The second one says, what is the y-intercept? Where does it cross the y-axis? It crosses the y-axis right here at 6. And so that point is at 0 comma 6. My x value was 0, my y value was 6. And number 3 says find the x and y intercept of a line whose equation is 2x minus 3y is equal to 12. The way that I teach this is we're going to write the equation twice, once underneath the x-intercept, once underneath the y-intercept. So 2x minus 3y is equal to 12, and 2x minus 3y is equal to 12. So if we're trying to find the x-intercept, that means my y value is 0. So we mark out my y value, and I'm left with 2x is equal to 12. I'm solving for x, so I divide both sides by 2. I get x is equal to 6. Now this is not my x-intercept because I want it to be in a point. So that is at 6 comma 0. That is your x-intercept. To find the y-intercept, you cross out your x value, and you're left with negative 3y is equal to 12. I divide both sides by negative 3. I get y is equal to negative 4. Again, y equal negative 4, that is not my answer. I want it to be in point form. That is 0 comma negative 4. Now, the reason I know that we plugged in a 0 for y is because we crossed it out here in the x-intercept. Negative 3 times 0 gives us 0. That's why I'm able to say that I'm left with 2x is equal to 12. Same thing when I go to find my y-intercept. When I plug in a 0 for x, that cancels, and I'm left with negative 3y is equal to 12. That's how I know that my y is 0 in my first point, and my x is 0 in my second point. The final two ways to determine the x-intercept and the y-intercept for a line is on a graph. Okay, is on a graph and also in a table. So if we're looking at a table and I'm trying to find the x-intercept, to find the x-intercept, I want to know when y equals 0. So if I take a look at this bottom row, y equals 0 right here. And so my x-intercept is at 3, 0. I'm looking for my y-intercept. I'm looking for where x is equal to 0. So I look at my x line, trying to figure out where it's equal to 0. It's equal to 0 right there. That tells me that my y-intercept is 0, 12. Finally, we take a look at the last example for this video. Find the x and y intercepts of the lines shown. Okay, so where's across the x-axis? If you notice, we have a horizontal line here. Horizontal lines never cross the x-axis, and so my x-intercept is going to be none. D and E does not exist, however you want to write it, but it will never cross this line right here that I highlight in red. It will never cross that line right there. But since it'll never cross that line, our answer does not exist. Then it says, hey, where is my y-intercept? Well, my y-intercept is where it crosses the y-axis. That is at 2. So that point is at 0, 2.